Welcome everybody to the second version of this Apache Tomcat HTTP2 Quick Start webinar. Thank you all for joining us. Let's get started. So the agenda for this webinar is I'll give a quick introduction as to who I am, talk about the background of why we might want to use HTTP2 with Tomcat, then go on to look at the prerequisites to get this set up, installation configuration, testing to make sure it's working, and then using it in your applications. We'll wrap up with questions. If questions occur to you as you're going along, please just enter them in the chat window. Make sure they're sent to either me or everyone, and then I will come back to the questions at the end and run through them. So, quick introduction. My name is Mark Thomas. I have been an Apache Tomcat committer since 2003, and I wrote Tomcat's HTTP2 implementation, hence why I'm giving this webinar today. I'm also the Tomcat 9 release manager, the Tomcat 8 release manager, and I have a few other responsibilities around the ASF as well. My day job is at Pivotal, where I get to spend about 90–95% of my time working on Apache Tomcat. So, why HTTP2? Well, the short answer would be because the servlet spec says we have to in Tomcat 9, but there are good reasons for implementing HTTP2. Fundamentally, it offers a number of advantages compared to HTTP 1.1. First of all, it's secure by default. There is a clear text version of HTTP2, but if you look at the browser implementations, most of the browsers aren't even bothering implementing it. It's more the command line tools like curl that are implementing the clear text version as well. So it's secure by default. Everything runs over TLS. You also get improved performance. That's for a number of reasons. First of all, because all of the requests and responses are multiplexed over a single connection. So rather than if you need to request multiple resources in parallel, opening up multiple connections, with HTTP2, it can all go over a single connection. So you get greater concurrency. For example, by default, Firefox will allow up to 200 concurrent requests, and lower latency because you don't have the TCP setup time for all of these additional connections. So that's one area where you get improved performance. The next one is header compression. If you've ever looked at HTTP 1.1 on the wire, it's rather on the verbose side. And a lot of it is very repetitive, so there's a lot of scope there for compression, and that has been taken advantage of in HTTP2. So it makes the volume of data that goes back and forth a lot smaller. And finally, there's server push. And the idea here is if you have a resource, let's assume it's a typical static web page, and you know that a request for that resource is pretty much always going to be followed by a request for the images, a request for any JavaScript, a request for the style sheet. Rather than having the latency of sending that resource back to the client, waiting for the client to parse it, working out what resources it needs, and the client then sending the next set of requests, as soon as the server knows that the client is going to need those resources, then it can use server push to start sending them to the clients straight away. So you significantly reduce latency. And the best bit is all of this, well, with the exception of server push, where you do have to do a few things, it's all available with no changes at all required to applications, as we'll see in a little bit. So if you want to get started with HTTP2 and Tomcat, then you're going to need a few things. The first thing you will need is the Apache Tomcat 9.0.0.m1 milestone, which you can download from the Tomcat website. It is worth emphasizing that this is a milestone. The specs are still very much in flux. They're not due to be finalized until the first half of 2017, which in reality probably means June 2017, so we're a good 18 months away from that. The servlet spec work has started, and that's where the HTTP2 API work has come from, but there's been no movement on the JSP specification. Okay, to be honest, it's likely to be a maintenance release released pretty much towards the end of the Java EE8 cycle, but there's been no movement on expression language, and I have no idea what's going to happen there, and there's been no movement on WebSocket, and again, I have no idea what's going to happen there. So there are lots of things that are still going to change. So Tomcat is going to change, some of the configuration options might change, some of the Tomcat internals might change, certainly some of the specification APIs are likely to change. So just keep that in mind when you're working with Tomcat 9 for the moment. Tomcat 9 requires Java 8. That's a requirement of the Java EE8 specification that it must run on Java 8. And if you want to use HTTP2, then Tomcat also requires that you use the APR native library. And you need to use the newer releases of this, the 1.2.x releases, of which at the minute 1.22 is the latest. And the reason for that is that HTTP2 requires a couple of TLS extensions. The first is Application Layer Protocol Negotiation, or ALPN. This allows the client and the server to agree which protocol they're going to talk as soon as the TLS handshake is finished. And in this case, they're going to agree to talk HTTP2. SNI is server name indication, and that allows virtual hosting to occur over TLS connections. So the client uses the SNI extension to say which virtual host it wants to connect to. The server is then able to use that host information to select the right server certificate to present to the client as part of the handshake. And the reason we need to use APR is basically Java doesn't support these. Java 8 doesn't support ALPN at all. Java 9 will probably support it, but we have to be able to run on Java 8. And Java 8's SNI support is essentially useless. Java 8 TLS implementation is limited to only having one certificate per listening server socket. And obviously, if you're doing virtual hosting, you need one certificate per virtual host, all related to the same socket, and JSE just doesn't support that. So in order to support that, we use the APR native connector, which in turn has access to OpenSSL, and OpenSSL supports SNI and ALPN as we need to. Just a little bit more detail on the native connector. It is included in the 900M1 binary distributions. If you've got a Windows binary distribution, then the Windows DLL, a precompiled DLL, will be included. Make sure you get the right Windows distribution for the JVM you're using. If you're using a 32-bit JVM, you need the 32-bit Windows distribution. If you're using a 64-bit JVM, you need the 64-bit Windows distribution. For Linux, the Tomcat Native 122 source is included, but it does mean you need to compile it yourself. Please note that you need a relatively new version of OpenSSL 1.02. That should be fairly simple to compile. If you have any difficulties, please do ask on the users list. If we find that lots of people are having difficulties, then we'll probably do another webinar just focusing on compiling Tomcat Native, but it should be a fairly simple exercise. So once you've got your prerequisites together, installation is fairly simple. If you install Java, unpack your Tomcat distribution. If you're on Linux, you need to build Tomcat Native, and that's it for installation. It's very much like, in fact, it is a standard Tomcat installation, just with the additional requirement that you do need to make sure that you've got the APR native connector available. In terms of configuration, and this is configuration to get us up and running with HTTP2, you need to do a couple of things. Obviously, you need to set Java home. Now, you can either do that in a setenv file, setenv.bat for Windows, or setenv.fh for Linux, or you can do it on the command line. When I do the demo in a little bit, I'm going to be doing it on the command line just because I find it a little bit faster, and speed's kind of important for demos like this. If you're on Linux, you'll also need to set the Java library path. So that will be setting javaops to minus the java.library.path to wherever you've installed the Tomcat native library. You don't need to do that in a Windows binary distribution because we dropped the DLL in Catalina base bin, and that's one of the places that Tomcat looks for it automatically. Obviously, if you want to put that native library somewhere else in the file system, then you'll need to set the Java library path appropriately. So once you've got Java set up, Java home, so Tomcat knows where Java is, and Tomcat knows where the APR library is, then in server.xml, you just need to uncomment the HTTP2 connector. There's a sample one there that's pretty much ready to go, and you need to add your TLS key and certificate files. Because this is OpenSSL, it uses the OpenSSL style files. One of the things that has happened post the 9.0.0 M1 release is the ability to use Java key stores with OpenSSL, but we'll come on to that in a later webinar. With this particular release, you do need to use the OpenSSL format files. So any of the online examples of how to set up a certificate file for HTTPD will work equally well with Tomcat and the APR connector. So let's run through a quick demo of setting that up. So here I've got my various prerequisites. I've got my Tomcat distribution, which I am going to unpack. There we go. That's all good. And let's go and set up my configuration. So go and, oops, wrong one. Open up server.xml, scroll down to the HTTP2 connector. This is one here, so I need to take the comments away from around the connector. Make sure I get the end comment as well. And you'll notice a few differences with this connector compared to what you might be used to from Tomcat 8 and earlier. This part of the connector is pretty much the same. Then you see we've now got some nested elements. First of all, there's this upgrade protocol. The upgrade protocol is the code that tells Tomcat what to do once ALPN has negotiated HTTP2. So that handles the HTTP2 communication. This SSL host and certificate, all of these attributes used to be on the connector, but now we're supporting TLS virtual hosting. We need to be able to have multiple hosts per connector. So the host configuration has moved to this SSL host config element that's nested within the connector, and then the certificate information has moved to the certificate element that's nested within the SSL host config. This means you can have multiple certificates for a single host. So here we're set up with an RSA certificate, and one of the things I got wrong in this release was I thought you could combine the certificate chain and the lease certificate in a single file. You can't. So that example is going to get fixed for the next release. I just need to edit that name. So that's our RSA certificate there. We could also add a DSA certificate and an EC certificate, and what that would do would give the client an increased choice of ciphers that it would then be able to use to communicate to the server. So we can have multiple certificates within a single SSL host config, and we can have multiple SSL host configs within a connector, and then each of those SSL host configs, they would represent one of our TLS virtual hosts. Now obviously in this example it's fairly simple. We've just got one certificate, one SSL host, one connector. But to say we can have multiple hosts and multiple certificates. So that's my configuration set up. Let's see whether it works or not. So it would help if I was in the right directory, wouldn't it? It would also help if I could type one-handed. Okay, so, whoops, there we go. One-handed typing, never good. Right, so in the right directory, I'm going to go into the bin directory. I need to set up Java Home, which, as I say, I'm going to do on the command line just because it's easier for me to do, particularly one-handed, than it is to set it up with a file. Whoops, that right. And we want Java 8. No, Java 8, there we go. Now, we should now be able to start up Tomcat. Yes, it's picked up the right JRE, excellent. And what have I done wrong? I failed to copy the certificate files. That's what I did wrong. That's what those error messages are telling me. So let me just go and fix that. I need my certificate. Copy. Put that in the conf directory where that sample expects to find it. And I also need the key. Copy. Go and put that in the Gatlin base conf. Right, okay, let's try that. Whoops, wrong one. Right, let's try that again. Before we do that, it's probably worth just looking at these error messages. So we've got unable to load certificate file, error, no such file or directory. That's pretty obvious. Yeah, so excellent. Let's try that again. Now I've got the files in the right place. That looks a little bit more like it. Okay, so if we scroll across so we can see the good stuff, the bit we're looking for in particular is this bit here. The HTTPS APR connector on port 8443 has been configured to support negotiation to H2. H2 is the encrypted form of HTTP2. H2C is the unencrypted form via ALPN. So that tells me that everything is set up as desired. Excellent. Okay. Let's just pop back to the presentation for a second. So that's a message we need to look for. If you want more detailed logging, so you can see exactly what's going on at the HTTP2 level, then you can enable debug logging, and there's a commented out section in the logging.properties file. I'll show that towards the end of the presentation. So what I'd like to try and do is demonstrate the performance. Now, this is always going to be a little bit touch and go, partly because I'm testing locally, and a large part of the benefit of using HTTP2 is reduced network latency. And of course, on a local test like this, then there isn't going to be very much network latency. But let's try it and see what happens. Maybe the demonstration gods will be on my side. Whoops, moved too early. Jean-Frédéric, one of my fellow Tomcat committers, has an HTTP2 test case. It's available on GitHub. It's very simple. It's a script and a couple of files, and when you run the script, it generates a single HTML page that has just over 600 embedded images. And it's been a very useful test case, both to test the performance of HTTP2, but also just to test that HTTP2 is working the way that we expect. So having already set that up, let's go and install this test case and see what happens. So that's an exploded directory in H2 test, so we'll copy that. We'll go and drop it in the web apps directory, and this is a default Tomcat install. So dropping that in there is going to trigger automatic deployment. Just as soon as, there we go, I remove the mark. So that's been deployed. Excellent. So let's fire up Firefox and take a look at what we've got. Now, to use HTTP2, obviously it's got to be over HTTPS. So there's the test page. Let's fire that up. Right, how long is it going to take this time? Relatively long period of time, 12.3. Let's just refresh it. I think there's some initialization going on the first time you run it. It makes it a little bit, there we go, it's like 5 seconds. That's a little bit more reasonable. I've seen it down as low as 2.5. It is very variable. Why it's very variable is on my list of things to investigate, to figure out. If we go and look at the HTTP 1.1 version, so without the encryption, and not using HTTP2, despite what the title says, we'll probably see similar sorts of performance. Yeah, around 12 seconds first time, and is it faster this? Yeah. Okay. Now, certainly what users have reported is when this is used in a rather more realistic scenario, particularly over a network, then just switching to HTTP2 is giving them anything up to a 20% performance improvement. So even though you've got the overhead of TLS, you get performance benefits because of the concurrency you get from having all of the multiplex streams on one connection and from the header compression. So if you want to use HTTP2 in your applications, what do you need to do? Just switch back to the presentation for a second. Essentially, it's just enable an HTTP2 connector. That's all you need to do. Now, if you want to do server push, then you do need to do a little bit more. Now, the important part of server push is working out what you actually want to push, because sometimes pushing makes sense, sometimes it doesn't. It depends a lot on what has the client already cached, and the server doesn't necessarily know for sure what the client has cached. So HTTP2 has a very simple approach to it. It will push whatever it's told to push, and the servlet API has replicated that. In terms of the intelligence that works out what should be pushed, what shouldn't be pushed, that is going to sit in a layer above the servlet API in whatever frameworks you're then using to write your web applications. But for now, we do some simple server pushes just by using the servlet API directly. It is worth pointing out that because this is servlet 4, it's not finalized. It's very likely to change. There's some discussion happening in the last few days on the servlet expert group as to exactly what this API should look like. And in addition, Tomcat's implementation is a work in progress. If memory serves me correctly, the only bit that I haven't implemented for server push is copying across the query string from the original request to the pushed request, but there might be some other bits and pieces that have been missed as well. If you spot something, just pop a question on the users list and I'll take a look. So there is a simple push example in the examples web application. Let's go and take a look at that. Right. Of course, if I could avoid the... Okay, let's do it this way. Yeah, the WebEx control panel keeps dropping down exactly where I want to use the mouse. Right, let's do it the other way then. So, if we go and look at the Tomcat source code, and web apps, example web applications, webinf classes, HTTP2, and we've got simple image push. Let's have a look at that source, scroll down, and zoom in just a little bit. What we have here is a very simple servlet, and the server push is just those two lines. So this is standard servlet do-get method. As you can see below, it's generating the body of the response, but before it does that, it pushes the image that it's going to then reference in the response out to the client first. And it's as simple as you take the current request, you get the push builder from it, you modify, and that push builder is pre-populated with the attributes of the current request. As a minimum, you're going to need to modify the path because you obviously don't want to push a duplicate request. So here we're modifying the path to the image, and we're just saying push. That call to push does two things. It tells the client to prepare to receive this pushed resource, and it also spins up a thread in Tomcat, passes, actually it takes a thread from the existing thread pool rather than starts one up. It takes that request, processes it through the normal request processing chain, generates the response, and starts writing that response back to the client. So this image is being written to the client before this page has even finished rendering. So that's what it looks like in code. Let's just go and have a quick look at what it looks like on the screen. Servlet examples, it's right down at the bottom, simple image push. Now, that's not particularly exciting, partly because I'm not the world's greatest web developer, but partly because it's actually very difficult to see that that image is pushed before the response. So what we can do is if we go back to Tomcat, and go and modify the logging configuration. Let's turn on the debug logging for HTTP2. And we'll just need to stop Tomcat and restart it to pick up the change in logging configuration. And then I am going to go and re-request this page here. Okay, there we go. Right, now we should see screenfuls of logs. Yes, there we go. Scroll across. And you'll see lots of useful debug information. Essentially, it's showing you step-by-step what's going on in the HTTP communication. If we follow around the top of the window, that's the connection opening. Each connection is given an ID starting at 0, incrementing for each new connection. And then within a connection, there are multiple streams. If you see a reference to stream 0, that's actually referring to the connection settings, the settings for the connection itself. Odd-numbered streams are streams that have been initiated by the client. Even-numbered streams are streams that have been initiated by the server. So what you see here is the first thing the client does is it initiates a bunch of streams, 3, 5, 7, 9, and 11. and it's not actually going to send any requests on these. What it's doing is setting different priorities for those streams. So it can, for subsequent requests, it can then make them dependent on those streams, which effectively enables it to control the priority of the subsequent requests. Tomcat will honour those priorities if there is limited capacity to write data back to the client. If for whatever reason the client is saying, oh, I can only accept a small amount of data, then Tomcat will use the priorities in order to work out which responses to write back to the client in what order. So that's streams up to stream 11. Then we see stream 13 appear, and followed a little bit later by the headers. You'll notice some of the headers have got colons in the name. They are pseudo headers because they don't actually, you can't actually pass the HTTP request line in a header, or you can't pass it in HTTP 2 because HTTP 2 doesn't have the concept. So effectively those pseudo headers are the request line translated into HTTP headers. So that's how the client passes that part of the request to the server. So I just scroll back down, back up again. So then we see 13 being processed, and while 13 is being processed, you see 2 starting up, and that's the server push coming from the server, and then you'll see 13 and 2 being progressed in parallel. They're on separate threads, and they're actually being processed pretty much in parallel all the way down until we get to the point where they have been completed and both of those streams are closed. Then we get various ping messages, and then when the client drops the connection, ooh, I was half expecting to see a stack trace there. You do occasionally see stack traces when the client closes the connection. That's one of the things that we need to clean up in the milestone release. Now, this HTTP debug log, it's what I use when I'm developing HTTP 2 and things aren't quite behaving properly. So if you see something happen that doesn't seem quite right, then the best thing to do is narrow it down to the simplest possible test case you can, turn on the debug logging, and then see if that gives you some clues as to what's going wrong. If it doesn't post the debug logs to the users list, if it doesn't tell you something, it might tell me something. Failing that, we can take a look at your test case, open up a big Bugzilla entry, and figure out what's going on. Ah, there we go. There's the I/O exception as the client closes the connection. I really must do something about that. Right, let's just shut Tomcat down, because that, I think, brings us to the end of the presentation. Yes, it does. So thank you very much for your attention so far. Now's your opportunity to ask some questions. Okay. Right, do remember just type the questions into the chat window and I will work my way through them one at a time. So the first question, how can you inspect the wire protocol if you want to see what the application is requesting from the server? 2 options. First of all, if you can persuade a client to talk H2C, that's the clear text version of the protocol, then you can just use Wireshark like you would normally, and Wireshark's able to decode HTTP2 and show you what's going on. If you can't do that, if you're testing with a browser, then it is possible to configure the browsers to log the session keys that they're using for TLS, and you can then configure Wireshark to pick up those session keys. It can then use it to decrypt the TLS data, and you can then see the wire level information flowing across. I've had to do that a couple of times to do some debugging. It's a little bit tricky to set up, but once you've got it set up, then it's fairly easy. Follow-up question to that is, what about Fiddler and Friends? Yes, if we just start Tomcat back up again, I will show you the Firebug version of it. What it looks like the browser vendors have done, and it is very much what it looks like what they've done, I haven't delved into it, is they've essentially done the HTTP 1.1 to HTTP 2 conversion sort of away from the normal extension point. So if you look at Firebug, and I just do a refresh, what it shows you is it says, oh no, I sent an HTTP 1 request. Look, here's my request line, here's my host headers, and I know full well that it didn't. And the only hint that it didn't is if you look at the response headers, you'll see that it mentions HTTP 2. So what it looks like, the the conversion to HTTP2 is happening fairly low down within the browser. So tools like Firefox just see it as HTTP1. I haven't come across yet any way other than Wireshark to see exactly what's going on the wire. Certainly when all the browser tools I've looked at, you see an HTTP 1.1 translation of what really happened in HTTP 2. Okay, any more questions? Right, I'll just tidy this up. We'll see if anybody else has got any more questions. Close that down. Stop Tomcat again. Okay, well, if any questions do occur to you, then as always, you are free to ask them on the Tomcat users mailing list. I will be putting up a recording of this webinar onto YouTube just as quickly as I can convert it and upload it. I will be posting to the users list once that's available. Thank you all very much for attending this evening. I hope you found it useful, and keep an eye out on the users list for the recording. Thank you very much.